Hi everyone, today I'm going to give a presentation for the paper Assistive Technology 80 Manual Accessibility Testing in Mobile Apps powered by Record and Replay. To get started with, we know that nowadays software and digital technology are part of humans' daily lives, especially mobile devices. Billions of people use them on a daily basis. With a few taps, we can order food from DoorDash, we can connect friends from Facebook, we can book flights from Expedia, and we can look up the word definition inside a dictionary app. However, among all the mobile device users, we often overlook people with disability, and it's estimated that around 50% of the world population have some form of disability. Recent study they just found many popular apps are shipped with accessible issues, no exception for those four. So why mobile developers will create inaccessible apps? The following slides better illustrate the challenges mobile developers are facing. So first of all, previous study found mobile developers they still prefer manual testing during the development. So they will use touch gesture to verify the correctness of their functionalities. For example, we're inside this budget tracker app, and we want to test whether this app button next to salary or wages will work or not. So as a developer, we're going to use our finger to single tap on this app button. And after tapping, there's a pop-up window appears to inform us two types of numbers for salary and wages. After seeing the result, developers might think, okay, this meets my expectation. There's nothing wrong with this app button, so I'm going to test the rest of the apps. The thing is, people with disability, they usually can't use touch gestures. Instead, they rely on assistive technology, or AT, to help them interact with the apps. And there are various assistive technology available in the market: talkback, switch access, and voice access. And each assistive technology has different interaction modes. Take talkback, for example. So blind people will use talkback, the Android screen reader, to help them navigate through mobile applications. So let's see how blind people use talkback to interact with the same app. The difference is that blind people they cannot see anything on the screen, so they rely on talkback to go through elements one by one, and they rely on talkback uh, to announce the textual description of the element, so that they can determine whether this is the element they want or not. So we're gonna start exploring the screen by using talkback. So firstly we do a swipe right. We focus on the element and talkback announce select categories. So we know it's not the one we want. And we do another swipe right. And this time talkback focus on disposable incomes and announce it. It's still not the one we want. So we might need to do another swipe right. And talkback focus on a different element announced as add new category button. Sadly, this is still not the one we want. So we might need to do an additional swipe right. And this time, luckily, TalkBack focused on the element and announced add button to us. So we know, okay, this is the one we want. Once located the element, so we're going to double tap on the focus element. That's an equivalent action for the single tap when we use the touch gesture. So let's see what happened. Oh, nothing happens here. So after we use the double tap for the focus element, nothing happens here. So what we expect here is we want to see a pop-up window to appear, but that's not the case for using talkback. So that means there's an accessible issues associated with this app button. So why mobile developers will ignore those kind of issues? It's because they do not have enough knowledge of assistive technology. At this point, some people might argue, okay, I know this time manual testing does not work. How about, existing automatic accessibility testing tools? For example, Google Accessibility Scanner. Okay, let's see what kind of results Google Scanner can give to us. So we scan this add button, and Scanner provides three suggestions to improve the accessibility. For example, to make the add button much bigger, to make the contrast much better, We can see that Google Scanner does not consider the use of AT, so that's why Google Scanner cannot report the issue associated with add button to the developers. Considering the current situation, so we would like to develop some tools to still allow manual tester or developer to assess their apps using touch gestures, while we can detect accessibility issues inside their apps. The detection of accessible issues should not require prior knowledge of AT from developers. Based on those insights, we proposed accessibility puppetry to aid developers in gaining insights about accessibility issue inside their apps. So our tool employs record and replay techniques, and there are 4 phases inside our tool. So firstly, we're gonna record touch gestures from developers and translate those gestures to the talkback actions and replay the talkback action in a different device. Finally, we're gonna analyze the execution result and generate visual report to the developer. And move on, this slide better illustrate how our tool will work. So again, firstly, developer can assess their apps using touch gesture manually, while our recorder will record those touch gestures. And after that, we will send the result from the recorder to the server. And at the same time, we will translate the touch gesture to the equivalent talkback actions. After receiving the talkback actions, talkback replayers inside our tools will replay them in a different device and send the result to the server. Finally, our tool will analyze the execution result and generates visualized report to the user, to the developer. So to evaluate the effectiveness of our tool, we conduct user studies. So we selected 5 apps with confirmed issues. And for each app, we designed a task consisting of 20 to 40 actions. And then we used a Fibo platform to conduct compatibility test and user interview. So during the test and interview, talkback user will perform our design task and report any of the accessible issue inside those tasks. So the reported issue will be regarded as a benchmark for our tool. So then we will use accessibility puppetry to record and replay the task and to see what kind of issues our tool can automatically detect. And finally, we compare our tool with existing tool, Google Scanner, and Latte. So through the user study, we found that our tool was able to detect many accessibility issues automatically. For example, unlocatable element. So this speaker button annotated by the pink box cannot be focused on by talkback. Talkback will just ignore this speak button. So our tool was able to detect those issues automatically. In addition, the ineffective action issue, that's the one we saw in our motivation example. So after we double tap on this add button, nothing happened here. So our tool again can detect those issues automatically. And finally, we'll compare our tool, the performance of our tool with existing tool, Google Scanner and Latte. And the comparison is based on the detection rate of the user confirmed issue. So overall, by looking at this table, our tool is able to detect over 60% of the user confirmed issues and outperform Scanner and Latte. So in conclusion, this presentation introduced a novel tool called Accessibility Puppetry to aid developers in gaining insights about accessible issues inside their apps. Our tool will record touch gestures from developers, replay the equivalent top actions, and generates visualized report to the developer. Through the user study, we found our tool was able to detect ineffective action and unallocated element issues automatically. So that's the end of the presentation. Thanks for listening.